variation in acceleration due to gravity with altitude, depth, latitude and shape of the earth. First we'll discuss about variation in acceleration due to gravity small g with altitude. Let r be the radius of the earth as shown as in the diagram. Capital M is mass of the earth and small g is acceleration due to gravity at the surface of earth. Consider small m is the mass of the body on the surface of earth here. Then the acceleration due to gravity on earth's surface is given by relation small g is equal to capital Gm divided by r square. This is equation number 1. This relation we have studied in the earlier topic. Now when the body is taken at a height h above the surface of earth as shown as in the figure, that is it is taken from the surface of earth at height h, then acceleration due to gravity will changes to gh is equal to capital Gm divided by square r plus h bracket square. This is equation number 2. Now divide equation 2 by equation 1. We get gh upon g is equal to gm capital Gm divided by bracket r plus h square divided by capital Gm upon r square. Now here capital Gm will get cancel out and therefore small gh upon g is equal to r square divided by bracket r plus h bracket complete square. Now we can write small gh is equal to g into r square divided by r square into bracket 1 plus h upon r bracket square. Here r square in numerator and denominator will get cancel out. This will become gh is equal to small g into bracket 1 plus h upon r bracket raised to minus 2. In this denominator term 1 plus h upon r square will becomes 1 plus h upon r bracket raised to minus 2 when it will go to the numerator. Now by polynomial expansion or for the small altitude h, that is for h upon r is very less than 1, then by neglecting the higher power terms of h upon r, above equation after expansion will become gh is equal to g into bracket 1 minus twice h upon r. This is equation number 3. This expression number 3 can be used to calculate value of acceleration due to gravity g at height h above the surface of earth as long as h is less than or very less than radius of the earth capital R. Hence the acceleration due to gravity decreases with increase in altitude, that is height from the surface of earth. Now we'll discuss about the variation. Now we'll discuss about variation in acceleration due to gravity small g with respect to depth below the surface of earth. The earth can be considered to be sphere made up of large number of concentric uniform shells. Then the total mass of the earth is the combined mass of all the shells, that is capital M. Now when the object is on the surface of the earth, then it will experience gravitational force as if the entire mass of the earth is concentrated at the center of earth. Then the acceleration due to gravity on the surface of Earth is given by small g is equal to capital Gm upon r square. This is equation number 1. This value is the acceleration due to gravity when the object is on the surface of Earth. Now, assuming that the density of the Earth is uniform, it is given by density, that is rho, is equal to mass upon volume. But volume of the Earth having the radius r is equal to 4 by 3 pi r cube. Therefore, substitute this value in this equation, we will get mass is equal to 4 by 3 pi r cube into rho. Therefore, equation 1 becomes small g is equal to capital G. And substitute here the value of mass in equation 2. This equation become small g is equal to capital G into 4 by 3 pi r cube rho divided by r square. Here r square in denominator and this r square from numerator will get cancelled. This will become small g is equal to 4 by 3 pi r rho into capital G. This is equation number 2. Consider a body at point P at a depth d below the surface of Earth as shown as in the figure. Now consider the point P or body at point P which is at a depth d below the surface of Earth, and the distance of this point P from the center of Earth is then r minus d. Here the force on the body at P due to the material outside the inner sphere can be shown to cancel out due to symmetry. Then the net force on the P is only due to the material inside the inner sphere of radius OP, that is r minus d. Therefore, acceleration due to gravity because of this pair at point P below the depth d from surface of Earth is given by gd is equal to gm dash upon r minus d square. This is equation 3, where m dash is the volume of inner sphere multiplied by density. Therefore, m dash will become m dash is equal to 4 by 3 pi into r minus d cube multiplied by rho, that is density. Thus equation 3 becomes, substitute this m dash in equation 3. Equation 3 becomes gd is equal to capital G into 4 by 3 pi into bracket r minus d cube into rho divided by r minus d square. Here r minus d square from denominator and r minus d square from numerator will get cancelled out. Therefore, this will become gd is equal to 4 by 3 pi into bracket r minus d rho into g. This is equation 4. Now taking ratio of equation 4 and 2 is divide the equation 4 by 2. We get gd upon g is equal to r minus d divided by r. Here, therefore, gd upon g is equal to 1 minus d upon r. This will become gd is equal to g into bracket 1 minus d upon r. This is equation number 5. This equation gives acceleration due to gravity at depth d below the Earth's surface, and it shows that the acceleration due to gravity decreases with depth. Means as the value of the d increases, then the acceleration due to gravity will also decreases. Special case, at the center of the earth, that is d is equal to capital R, that is depth is equal to radius of the earth, then this equation 5 will becomes gd is equal to 0, and hence the weight of the body of the mass small m is 0 at the center of earth due to absence of force of gravity. Graph showing the variation of acceleration due to gravity with altitude and depth. The value of acceleration due to gravity is calculated to be maximum at surface of earth, and the value of g goes on decreasing with increase in depth below the earth's surface, that is varies linearly with r minus d, or that is small r. Second, the value of g goes on decreasing with increase in height above the surface of earth, that is it varies inversely with r plus h square, that is equal to small r square. This is shown by the graph of small g as the function of small r, the distance from the center of earth, that is plotted in the given graph. Now for small r is less than capital R, that is inside of the earth, the graph is like this. Is gd is equal to g into bracket 1 minus d upon r. This is equal to small g into bracket r minus d divided by capital R, but r minus d is equal to here small r. Then the equation can be written as g of r is equal to g into bracket small r upon capital R. This implies that g of r is directly proportional to small r, and then the graph shows the straight line passing through the origin and having the slope small g upon r. Second, for the small r is greater than capital R, that is the distance of the object from the center of earth is greater than radius of the earth, that is for the altitude. Equation is gh is equal to g into bracket r square upon r plus h square bracket complete. Now if small r is equal to capital R plus h, therefore g of r is equal to g into bracket r square upon small r square. This implies that g of r is inversely proportional to r square, small r square, which is represented in graph. This graph shows that acceleration due to gravity is maximum when the body is at the surface of earth, that is small r is equal to capital R, and it decreases inside the earth means as the depth increases, and also it decreases with increase in altitude from the surface of earth.